Hi, this is Fazana again. In this video, we'll look at some circle theorem questions. As important as the circle theorems themselves, always remember to mark your radii. Yeah? The minute you mark your radii, you you get isosceles triangles. Yeah? So no matter how well you know your circle theorems, if you can't locate your isosceles triangles, your workings will just flop. Yeah? And start making the diagram your own as soon as you see it and as soon as you read every single word. Yeah, it's so satisfying when you've arrived at the answers even before you get to them. So you've marked all over the diagram and then you say, okay, now hit me with the questions. Yeah, all right. Okay, let's look at the questions. Okay, sorry, the diagram's a bit small here. So it's got, and you remember this theorem, yeah? So can you see, once you remember the theorem, you can go straight for it, yeah? You know, radius meets tangent, 90 degrees, radius meets tangent, 90 degrees. And remember I said because those two are 180, those two will be 180, so that's 140. Yeah? Okay, and again, if you remember the theorem where we drew it really well, we've got the arrowhead, so angle at the center is twice the angle at the circumference. Oh my god, that was so easy. What do they want to know? P and Q, obviously. Yeah, so work out the value of P. So P is 140. Okay, and then you've got to give the reasons. So the first thing you say is angle BCD and angle CBD equal 90 degrees. Radius meets tangent. Okay, so those two are 180, and then you just go angle P equals 140 angles in quadrilateral, sorry, I'll just put quad, okay, equals 360. Okay, as easy as that. Well, write down the value of Q, so that's 70. So the reason there is angle at center twice angle at circumference. Okay, I'm going to take even more shortcuts, but remember, write down the word. All right, okay. This is an extension of this question. So the tangent dB is extended to t. So once I look at that here, I say, oh, look, that's 90 degrees. So this time they seem to want that 90 degrees there. Yeah. The line AO is added to the diagram. And the minute I do that, can you see, I can say, oh, look, I can mark all my radii. Yeah, so can you see these are all radii, which makes it so much easier. Your life's just full of isosceles triangles. Yeah. Angle TBA is 62, so we can see that that angle there will be equal to 28. Yeah, so 90 minus the 62. So you can tell that angle there will also be 28. Yeah, not much space to write. Yeah. So you can see X will actually, this is an isosceles triangle, so X will be 180 minus 2 lots of 28, which is 56. So that would be 124. Okay, yeah, so that's 124. Okay, and we'll just put 1 there, so in case they need to find out what we were doing there. Yeah, okay, So again, you've got to do explanations. So you go angle TB, TBO equals 90 degrees. And then again, I'm going to take real shortcuts so you can see radius meets tangent. Okay, and then angle ABO equals 28, 90 minus the 62, and then angle X equals 124, and you go triangle AOB equals, is isosceles, 2 radii. Okay, yeah, good. So that's 124 there. Okay, what we haven't done is actually brought in all this stuff from here. So that is 140, and that whole angle there, yeah, is 70. So if that's 28, then that one will be 70 minus the 28, which will be 42. Yeah, so that means that's going to be 42. All right, yeah, okay. And then again, please do your explanations. Yeah, so then you have to say that this angle is 42 because the 70 minus 28. Yeah, okay, let's just do it. Let's do that there. Okay, so angle OAC equals 42, and then you go 70 minus 28, and then you go angle Y equals 42, and then you go triangle AOC, isosceles. Pencil seems to be giving up with me. Isosceles 2 radii. Okay, yeah, all right. So that was good, wasn't it? 42. Okay. One thing's a brilliant check. Can you see those two are 84? So that angle there will be 180 minus 84, which is 96. Yeah, and so this is just a check. 124 plus 140 plus 96, and if you add them all up, you get 360. Okay, so that's a brilliant check, isn't it? Yeah, okay. Okay, so let's have a look at the next question. ABCD is a cyclic quadrilateral, so what we do know is angles in a cyclic quadrilateral add up to 180. Okay, so those two and those two. All right, okay, so let's go for it. So we've got x plus 2y plus y plus 40 equals 180. Yeah, and let's just collect like terms and also minus the 40 while we're there. Okay, so we've got x plus 3y equals 140. Okay, yeah, you can already tell it's going to be simultaneous equations, yeah, because we've got x and y's, so we have two unknowns. All right, okay, so that's that first one. And then the second one was 2x plus y plus 20 equals 180. Let's minus our 20. So we've got 2x plus y equals 160. Okay, so that's our two simultaneous equations. Okay, let's just write them out again. So we've got x plus 3y equals 140. 2x plus y equals 160. Yeah, I always take this one here. Yeah, I always play around with the y's. Okay, so I'm going to multiply this whole line by 3. So I've got 6x plus 3y equals 16 times 3 is 48, so 480. And then I'm just going to copy that one there. So x plus 3y equals 140. Okay, now we're ready to play, and we're minusing because we've got two positives. Yeah, so same signs you minus, different signs you add for you to eliminate the y. Yeah, so you say you're gone. Okay, so 6x minus x is 5x, and then 480 minus 140 is 340. Okay, and if you divide by 5, x will be 68. Okay, yeah. All right, now we found our x. Let's go find our y. Which one is it easier to do in? We'll do it in here, so we'll solve it in there. Yeah, so you've got 68 plus 3y equals 140 minus the 68, and 3y equals 72. Divide by 3, and y equals 24. Okay, yeah, so x is 68, y is 24, and I'm just going to test it in here. So 2x, 2 times 68, 120, 136, plus 24 comes to 160. Yeah, so I've just tested it, and it so works. Yeah, all right. Okay. If you have the time, and if you finish the paper and you're checking it, or if it's worth 4 marks, yeah, then go and actually stick the figures in and make sure it works. So 2 times 160, 2 times 68 would be 136. 24 plus 20 would be 44. So you can see those add up to 180. Y is 24 plus 40 is 64. And 68 plus 2 lots of 24s, 48, will be 116. So you can see that works. Yeah, all right. So that's quite, it's like combining circle theorems with simultaneous equations. So many questions actually combine 2 topics. So it doesn't matter how well you know the circle theorems. If you can't hack simultaneous equations, then you can tell you've lost it. Yeah, all right. So you've got to know each and every topic pretty well. Okay, don't miss out any topics. There's always going to be a topic or two that you just can't seem to master. I'm that when it comes to 3D trigonometry. I can see it, I do it, but I don't feel as comfortable with it. And then the next time I do that same question, I go through that process again. I don't like it, but I have to do it. Yeah. So there's always going to be a topic here and there that just baffles you a bit. All right. Okay. Let's go to the next question. Diagram shows a circle center O. So again, the minute it's got a center, you know it's going to be one of the radius meets tangent, or angle at the center is twice the angle. Oh yeah, yeah. So here we've got our arrowhead. If that's 58, then 58 times 2 is 116. Yeah, so that's 116 there. Okay. The minute I've read one sentence, I then go mark my radii. Yeah. So then you can see that's isosceles triangle, and 180 minus 116, and then divided by 2, so that would give you 64 divided by 2, so you've got 32. Okay, so each of these is 32. Okay, and that's just from the first sentence. Yeah, TA is a tangent. My circle theorems with tangent is radius meets tangent. No, it's not. I haven't got two tangents, but the other one is the alternate segment. So you can see angle between the tangent and the chord is equal to the angle in the alternate segment. So you've got that triangle there. Yeah? Okay, so you can see that's 74. So that bit there would be 74 minus the 32, so that will be 42. Okay, yeah, we've still got the whole picture, haven't we? Yeah, okay, so calculate angle BOC. So we've got 116, and this one's quite an easy one. Angle at center twice angle at circumference. You're going to write it properly, aren't you? Yeah, okay. Angle OCA, so that is OCA, so that they're asking us for this 42 here. Now how did we arrive at that? Once we have the 116, we found the 32s. Yeah, so let's talk about that one being 32. So angle BCO equals 32. Yeah, and then the reason why is because triangle BOC isosceles to radii. Yeah, and then the alternate segment, so that whole thing was 74. So angle BCA equals 74, and you have to write the whole sentence, but I'm just going to write alternate segment. Yeah, so the angle between the tangent and the chord is equal to the angle in the alternate segment. Yeah, okay, and then you go angle OCA equals 42, because you've got your 74 minus your 32. Okay, yeah, that was good, wasn't it? Yeah, good. And sometimes when you get stuck, always ask yourself, why did they give me the 58? Why did they give me the 74? Because you know they've given you the number so that you need to use it. Yeah, so you get stuck, and just make sure you keep asking, why did they give me that? Why did they give me that? Yeah, all right. Okay, this one. P, Q, R, and S are points on the circumference of a circle. Okay, so it's not a cyclic quadrilateral, even though they're talking about 4 points. But as soon as I'm looking at this, yeah, I'm thinking, oh, that's our bow tie, isn't it? Yeah, so isn't that 56? Yeah, all right, cool. Can you see anything else at the moment? Let's carry on. Oh, PR is a diameter. Okay, so PR is a diameter, so you know that is 90 degrees. Yeah? The minute you draw that 90 degrees, you look at that triangle there. So those two will be 90, so that's 34. All right? Yeah? That was okay? Good. Okay, find the size of angle PQR. Okay, so we say it's 90, and the reason is angle extended by diameter. Okay, find the size of angle PRQ. Okay, so we know that's 56, and the reason why angles extended by same arc, or you can write same segments here, angles in the same segments. Angles extended by same arc are equal. All right, yeah. Okay, find the size of angle POQ. Oh, okay, POQ. So we have to draw that line there. Okay, the minute you draw that line and we want to find that angle there, yeah, just keep playing around with it. POQ, POQ. Oh yeah, I could mark my radii. Yeah, so you can see that will be 34 as well. And that will just be 180 minus 2 lots of 34s, which is 68. So we've got 112. Okay, and the reason for your answer is we have to talk about why that is 34 first. So the reason it was 34 is angle RPQ equals 34, and then you say triangle RPQ equals 180, so all angles in a triangle add up to 180, and then you say angle POQ equals 112, and triangle POQ isosceles 2 radii. Okay, yeah, all right. I'm just looking at this. Can you see? I don't know why it works right now, even though that's not quite an arrowhead. But I noticed that that angle 112 is actually twice that angle. Yeah, so you know angle at the center, twice the angle at the circumference. Yeah, oh yeah, we've got that arrowhead there. Yeah, so that angle there is twice that angle. Yeah, okay. And you can tell the same basis works because they're in the same segment, yeah, or they're extended by the same arc. Okay, so looking really closely, you can see that arrowhead as well. Yeah, okay. Okay, this one I just brought in. It's not a difficult one, but I just brought it in, and I think I mentioned it in part 2 as well. It looks so much like the bow tie, doesn't it? Yeah. Okay, and it looks like the bow tie. But remember, when you're talking about angles extended by the same arc or angles in the same segment, both these points have to touch the circumference, yeah? Whereas this one doesn't. So here, can you see it's actually angle at the center is twice the angle at the circumference, yeah? So it's a trick one, okay? So it's not the typical arrowhead, yeah? So double 48 would be 96, yeah? And so we've got 96 there, LOP. And the reason for your answer is angle at center twice angle at circumference. No, it takes ages to write these explanations, doesn't it? Yeah, alright. But you got to do it just to get your marks. Yeah, alright. Okay, that's all for now, just for this particular part. I hope these were fun to play with. Now watch part 4 and become smarter and more confident. Yeah, keep practicing. Remember, you're in control, and see you in part 4. Take care. Bye.